Next chapter, geometric constructions. Geometry is a branch of mathematics concerned with shapes, sizes, relative positions of figures, and the properties of space. And plane geometry is all about plane figures. If you're going to be doing constructions, you will need these three equipments. First, a ruler, at least 15 centimeters in length, preferably transparent and with all the marks clearly visible. A protractor and a compass with a sharp pencil. The hinges shouldn't be too loose or too tight. For the larger part of this chapter, we will learn constructions using a ruler and a pair of compass only. So are you ready? I am. Let's get going. We start with construction of perpendicular bisectors. And the first one is a perpendicular bisector of a straight line. Bisect means dividing into two, and perpendicular means the bisector meets our line at 90 degrees. So essentially we are constructing an angle of 90 degrees. So this is the line. Our bisector will divide it into two equal halves. We place the compass at one end of the line. We then open the compass to more than half the length of the line. It's really important you do that. It has to be more than halfway along the line. Then we move it up and make an arc from the top to the bottom. And that arc has intersected the line. Now we move the compass to the other end without changing its radius, that is the distance between the pencil and the needle. We will make another arc from up to down, and you should see that the two arcs intersect at 2 points above and below the line. The last thing is to draw a vertical line joining the 2 points of intersection. And that line is a perpendicular bisector of our line. And you can confirm that the length on the left equals to that on the right. Again, the angle here is 90 degrees. Next is a perpendicular at a given point on a straight line. Now the bisector does not always have to cut the line into two equal halves. Perpendiculars can be drawn anywhere on a straight line. First, there is our straight line. We choose a point anywhere on the line and our perpendicular will pass through there. Next, we put the needle of the compass at the point. Then we choose a comfortable radius and make a semicircle. Then I'm going to choose another radius bigger than the first one. We place the compass at the intersection here and mark an arc above the point here. Then, without changing the radius, place the needle on the other point and again make another arc. Now put the compass aside and using a ruler, join our point to the intersection of the two arcs. And basically what we have done is draw a perpendicular through point O. Next is a perpendicular from a given point outside the line. In this case, we say we are dropping a perpendicular to a given line from a given point above or below the line. So there is the line. We want to construct a perpendicular to that line, but importantly, it has to pass through point P. So place the compass at point P. Open it sufficiently and mark an arc that cuts the line at 2 points. Then place the compass at one point of intersection and make an arc. Place it on the other point and make another arc. The last part is to draw a straight line through the 2 intersection points. And so we have dropped a perpendicular to AB from P. Next, parallel lines. Parallel line through a given point. For example, we want to draw a parallel line to this line, but the second line must pass through the red point. We do this using corresponding angles. So we first draw a transversal through the point. Any angle will do, it's just a random line. Let's have this point as A and this one as B. And so basically we want to reproduce angle A at point B. Place the compass at point A. Open it and make an arc that intersects the 2 lines. You can label these intersection points C and D. Without changing the compass radius, place it at B and again make an arc. Now the next step is important. You take the compass and measure the length CD. Please note we are measuring the straight distance CD. Be very accurate. You can test that by making a small arc, but it's not necessary, it's just to be sure. Then without changing that radius, place the compass at this point of intersection. You can call it E. Then make an arc that intersects the red arc. We can mark the point as F. Now the thing is, CD is equal to EF. That's basically why we were measuring length CD. The only thing to do now is draw a line through B and F. And you can be sure that that line is parallel to our original line below. Why? Because angle CAD is equal to angle EBF. So that's how you reproduce angles and how you get parallel lines. Next is dividing a line proportionally. A line segment can be divided into equal parts using two methods. The simplest is using a set square. So let's say we have line AB and we wish to divide it into 5 equal parts. First step is to draw an inclined line to our original line. Let's say from point A. Again, any angle will do. Now take a compass and set it to any radius, say 2 centimeters, and make 5 arcs on the new line. Four, and 5. Then we join the last point to our point B. The only thing you need now is to draw parallel lines to this line from all points. The parallel lines will cut AB into 5 equal parts. If you don't have a set square, you can reproduce the angles to create parallel lines. Next, bisecting an angle. When we bisect an angle, we simply divide it into 2 equal halves. In fact, when we construct a line bisector, what we are doing is simply dividing an angle of 180 into 2 equal angles, each of 90 degrees. So let's bisect this acute angle. Place the compass at point A. Open a convenient radius and mark an arc to intersect both lines. You can label the intersection points B and C. Next, open the compass and place it at B, and then mark an arc here. Using that same radius, put the compass at C and mark another arc. The angle bisector should pass through this point of intersection. All you need now is get a ruler and draw that bisector from the vertex at A. Constructing angles. The angles 60 and 90 degrees can be constructed using a compass and a ruler only. We already know how to construct an angle of 90 degrees. Now we look at how to construct an angle of 60 degrees and 120 degrees. So here is the line segment PQ, and I want to construct an angle of 60 at Q. So I place the compass at Q and swing an arc to cut the line PQ. Now, maintaining the same radius, I place the compass at this point and again swing an arc to cut the first one. And if I join point Q to the point of intersection, this angle is 60 degrees. Now to construct an angle of 120, you can just construct another 60 degrees on the new line. But there is a direct way of doing that. When you get to this point while constructing 60 degrees, maintain the same radius and place the compass at this point and mark an arc there. If you join Q to this point, the angle is 120 degrees. Angles like 30 degrees and 45 degrees are constructed by bisecting 60 and 90 degrees respectively. Next is construction of polygons, and we start with triangles. First triangle, given the lengths of the three sides, and we are going to construct a triangle PQR measuring 11 centimeters by 7 centimeters by 8 centimeters. Take a ruler and draw a line 11 centimeters. You can label the points PQ. Now we find where R is. Take a ruler and a compass and measure 7 centimeters. Draw a big arc from one side of PQ. We do above P. Then take the compass and the ruler and measure 8 centimeters. Go to the other point Q and do an arc. The point of intersection of the arcs is the point R. All you need to do is to complete the triangle. The next triangle is when given 2 angles and 1 length. We will construct triangle MNO, where NO is equal to 9 centimeters, angle MON is equal to 65 degrees, and angle MNO is equal to 43 degrees. We start with the line 9 centimeters. That is NO. So at O, we measure 65 degrees. Protractor on the line. "65 degrees" is here. We draw that line. So M lies anywhere on that line. Next, at N, we measure 43 degrees. Here. Draw that line. And there you have point M. The last triangle is when given 2 sides and the enclosed angle. We will construct triangle ABC, where AB is equal to 12 centimeters, BC is equal to 7 centimeters, and angle ABC is 51 degrees. We start with the line, preferably the longer line. That is 12 centimeters. That is AB. We then measure 51 degrees at B using a protractor. (51) is here. Join that point to B. C is 7 centimeters from B, so measure that with the ruler. That's point C. And finally, join A to C and you shall have your triangle. Next, construction of quadrilaterals, and we'll start with the rectangle. To construct a rectangle, all we need are the sizes of the length and the width, because we know the angles are 90 degrees. I need to construct a rectangle with dimensions equal to the line segments A, B, and CD below. Alternatively, I would have had the actual length measured from the ruler. First is the line segment, and we construct a perpendicular to that line. So arc and another arc, and then the line, the perpendicular bisector, and we should be having an angle of 90 degrees. The length should be equal to AB. So I extend the line, then I'll measure AB. Take that length on my line. So this is M and this is N. Let me extend this just in case. Then I'll measure CD. Take the length up here. This is point P. So now O is somewhere here. Again, PO is equal to MN. And again, PM equals to NO. So I don't need to construct a perpendicular. From N, mark an arc the same radius as PM. So O is somewhere on that arc. Measure AB. Place the compass at P and cut an arc. That intersection is point O. Now just complete the rectangle. Now with that, you know you can construct a square. Next is a rhombus. We will now construct a rhombus with sides equal to that line. I measure it and it's 6.5 centimeters. So what I do is place the compass on one end of the line. Open it to the same length of the line and then create an arc. We then place the compass at any point on the arc, because any point on the arc is the same distance from point O. It's the radius of the circle. I will mark C here and then create another arc. Then move the compass down to B and again draw another arc. I'm sure you can now already see the rhombus. Now we take a straight ruler and connect all the points to complete the rhombus. Join A to C, then B to D. And finally C to D. And there is your rhombus. We can also construct a rhombus if we are given the length of the side and one diagonal. So in this example, we will construct a rhombus of side 6 centimeters with the longest diagonal being 10 centimeters. We already have the line here. We measure 10 centimeters, place the compass at one end and mark an arc. We measure 6 centimeters, place the compass here and cut an arc over there. Join that point and the diagonal 10 centimeters. We need to locate the last point. Measure 6 centimeters, place the compass here and mark an arc. Place it here and mark that arc there, and we have the last point, and now we can complete the rhombus. Excellent. The last quadrilateral is a parallelogram. The knowledge of the properties of a parallelogram is what we use to construct it. I'm gonna show you actually three methods of doing it, and you will choose the simplest that works for you. We start with these two sides and an included angle. The first method is based on the knowledge that the two opposite sides are equal. So I will need the upper side, which must be equal to the one I already have. So I measure this length, take the compass up here and mark an arc. So my point will be somewhere on that arc. Then I will copy this other side. I will measure this point and copy it here. And that's my point. So I just need to draw the two lines and have my figure complete. The next method is from the understanding that opposite angles in a parallelogram are equal. And so what we will do is simply copy this angle on the other side. The first thing I want to do is extend this line so that I copy the acute angle that will be formed below. Start at the vertex and draw an arc that cuts both the lines. Draw a similar one up here. Then another one here. We just want to do them all at once. Then we measure this distance. Copy that length here. And again here. So draw that upper line through here. And the right one through this intersection. There is the figure. The last method is based on the understanding that parallelograms have diagonals that intersect each other. Be careful though, the intersection is not perpendicular. Start with the two sides. That's one diagonal. The other diagonal will come through here and bisect this one. So I need to know the midpoint of this diagonal. I do like I'm constructing a perpendicular bisector. Mark an arc and the other arc. That line will tell me this is the midpoint. So the diagonal starts from here and will go through this midpoint. Now I need to locate the other corner. I know this is the midpoint, so it's just getting the same distance on the other side of the line. Measure that and copy it on this side. That is the point. And now I can complete the figure. Now for the other polygons, we often have to literally measure the interior angles to construct them. We first calculate the interior angle and then use the protractor to get the angles. There are, however, various methods of constructing regular polygons using a ruler and a compass, but these methods vary and are often complicated. Let's try a pentagon. Let's do a regular one with sides 3 centimeters. First, draw a line AB 3 centimeters. Draw a circle with center at A and radius AB. Draw a second circle with center at B and radius AB. The circles meet at C and D. Draw an arc with center C and radius AB. The arc cuts circle 1 and 2 at E and F respectively. Draw a perpendicular bisector of AB, which cuts arc EF at G. Now draw line EG long enough to cut circle 2 at P. Equally, line EG is extended to cut circle 1 at R. With P and R as centers and AB as radius, draw two arcs intersecting each other at Q. Finally, draw the lines connecting these points to complete the pentagon. The easiest polygon to construct is a hexagon. For a hexagon, the length of the sides equal to the radius of a circumscribed circle to that hexagon. Try constructing that. As for irregular polygons, there can't be any other methods apart from literally measuring the angles using a protractor and using a ruler to measure the sides. Good luck with geometry.
The way we teach it in university and in high school as well, in colleges, is if you fall behind, you're in desperate trouble. That if you miss a class or miss an idea or don't do your homework, you go to the next class and the teacher assumes you know it, but it's like Greek to you. And so the biggest challenge is not falling behind, and the strategy is do whatever needs to be done so you don't fall behind. Seek help wherever you can find it, from students, from student help centers, from the teacher, from the teaching assistant, wherever you can get it. Because if you fall behind, it's like you're missing a floor in the building, you're missing a brick in the wall, and you just can't build the second floor without a good understanding of the first floor.